take a look at some real examples. So here's the memory mapped I/O example from ARM. You might have heard of ARM, right? Most smartphone tablets now use ARM processor, and actually there are many kinds of ARM processors, and this one is kind of the lower end, really low power one called Cortex M0. This one actually supports 16-bit instructions, but its registers are 32 bits. Now, most ARM instructions are 32 bits wide, and of course, registers are still 32-bit. But if you take a closer look, okay, they actually divide the different spaces, or they divide this space into different regions. A lot of it for memory mapped I/O. So, right, as you can see, right, this is a 32-bit address space, so 2 to the 32 or 4 gigabytes of space. But you notice, if you can see down there, from address 0 up to 1FFFFFF, that's for code. In other words, that's the program part. And then from 2000 up to 3FFFF, right, that's the SRAM, or for your data. So that means you have half a gigabyte for program, or that's 512 megabytes, and then another half a gigabyte for SRAM. So code and data together occupies 1 gigabyte. For most embedded systems, that's plenty. That's a lot, okay? And then peripheral, well, that means the external devices, right? But in this case, these are, I think what they mean, they mean the really the integrated peripherals. Peripheral means around the processor core. That's another half a gigabyte, right? And so you've, out of 4 gigabytes, 1.5 gigabytes is used for code, SRAM, and peripheral. Still have plenty left, right? And then you have 1 gigabyte for external RAM. So that means if your internal built-in RAM is not enough, you can attach another memory module outside, okay? And these are all part of the same address space, 32-bit address space. And then another gigabyte of space for external devices. And then another one, well, the rest for private peripheral bus and more devices. Okay, so this is one example, one real example of how, like for example, the ARM architecture uses its address space. Okay, so this way they don't just need to use input and output. Well, they don't have to use input and output instructions. They just have to use like memory loading, storing to make the I/O happen. Okay, and of course, though some of these map to the general purpose I/O pins. Could be like the LED lights, right? So you can write to a certain location to turn on and off an LED light. Now, as an example of portedIO, well, we have the Intel 8051, which is the instruction set for the same processor that we used on the EcoPT here. Now, so this Intel 8051 has a couple different memory spaces. They have what's called the internal RAM and external RAM, and then code space. Now, internal RAM is using 1 byte pointer, which means it has 256 possible locations. It's divided into 2 parts. The lower part, that is the lower 128 bytes of space, is for data. That includes its stack. Now, the upper 128 bytes really for SFR, or special function registers. And you have to know the term SFR because this is what most microcontrollers provide their function. So you read and write these locations as special function registers. So if you want to do like turning on an LED, well, you write to a special function register. That is for the general purpose I/O port. You want to send a packet to a radio? Yes, that's another access to a special function register. You want to put the processor to sleep mode, yes, you write another special function register at a different location. Right? There's one special function register for a particular action, right? And so that so special function register or SFR are what allow the microcontroller to really be doing all these things. Now, and this is a separate space from the external data. So on 8051, the way you distinguish between internal memory and external memory access is you actually use different instructions. So they have an instruction called move, M-O-V. That's for internal memory access. If you have to access external data, you use move X, X for external. So just by using different instructions, you refer to different address spaces. Okay, so that's how, say, 8051 can access different kinds of memory. And there's also move C for moving code space. And on 8051, code space and data space are separate. So that means you can have an entirely separate 64K just for program. And even if you use the same address, that's actually different from the data space.